So our project was conservation of fun.
I'm Alex.
I'm Andrew.
I'm Ian.
So in this presentation, we're going to start by talking about the project planning. So how we pick the product, our target customer audience, so 11th grade teachers and students. We're also going to go over project management, so like our Gantt chart and our project timeline, explaining when we're going to do what. Our customer needs that we got from customers, saying that what they want to see in a product. The QFD, that's going to compare the target specifications we came up with based on those customer needs. Competitive benchmarking, which will compare our product that we're hoping to develop compared to other existing products. And an economic analysis to show that the product, what it will cost and how much money it will make for the company.
For our project planning, we developed 3 different projects. All 3 projects ended up being targeted towards 11th grade teachers and students. For the first project, we had conservation of energy, conservation of momentum, and springs. For the second project, we had conservation of energy, projectile motion, and springs. For the project 3, we had conservation of energy, projectile motion, and friction. And from those 3 projects, we developed an S-curve to develop which project would give us the best performance over time. And we determined that project 1 would give a small boost performance over a short period of time, while project 3 would have a larger performance value over a longer period of time. And project 2 would be somewhere in the middle. That helped us develop a resource allocation chart where we found 3 was the most expensive, 1 was the cheapest, and 2 was in the middle. And we determined that 2 would be the best project to move forward with. And we developed a mission statement for project 2, where our users would be 11th grade physics teachers and students.
This is the Gantt chart that we made for the project management. We made it based on the course outline for all the tasks that are going to be taught in the class. The first 2 tasks are the customer needs and the target specifications up here. Those are done simultaneously because they're both based on getting information from customer interviews. The next 2 tasks are the intellectual properties and the concept generation. Those were done simultaneously in order to save time. And then as you can see by the red status line right here, we're in the middle of concept testing for design phase 1. The rest of the tasks are done in sequential order based on what is needed in the course outline.
These were our customers. Unfortunately, none of them have responded so far, so we have used our customer profiles to develop our customer needs, but we'll use classmates to help determine more customer needs. For the QFD, we correlated the customer needs and specifications, and from that we determined the technical importance ranking, which was user calculation and choice first, followed by a tie between having 3 obstacles, modular assembly, and easy to understand instructions, with last being the price. And from that we determined, and after that we determined the technical difficulty of each specification to complete and develop. And we found that the most important specification was the user calculation and choices.
For our competitive benchmarking, we analyzed 2 other products that are similar to the educational training kit that we're making. The first one is by Pittsco Education. It is a roller coaster maker training kit. It comes with pre-assembled tracks that you can put together to create a roller coaster that you send these balls through. The adjustability is based on the tracks, and there's no way to test physics beyond whatever the tracks give you. So it's more restricted than the BRG that we're making. The product comes with a storage container which we could take and use in our BRG to have it more compact and a way to store for other uses. The cost of this product is about $580, which is much more than the estimated cost of our BRG, which we'll go over more in the economic analysis later. The second product that we analyzed is the Connects roller coaster physics kit. Over here you can see that it comes with a teacher's guide that comes with lab exercises that will teach the user physics through multiple labs. And the whole roller coaster is more adjustable because of all the individual Connects pieces, while our BRG is only adjustable in each individual obstacle, so the adjustments are more restricted, which we think will allow us to focus the adjustability of different physics parameters to teach different topics into 3 different spots instead of throughout the entire roller coaster. The cost of the Connects kit is about $280, which is still more than the BRG. So we think that our product will be more competitive than both of these products.
So for our economic analysis of our product, we determined a manufacturing cost of $42. This was based on the fact that the Arduino Uno is $25, and the breadboard we need to use is about $10, which takes up most of the cost of the product. And then we also estimated that it would be about $7 for the raw materials to build the board. And then this led us to decide a price per unit should be $75. We think this is a reasonable price, and most physics classrooms will go for this. It's cheaper than the competition as well. And then this gives us a profit per unit of $33 after the initial $10,000 cost is overcome. And so this leaves us with a break-even point of 304 kits sold to break even. This is a quite low number. We thought that at this price point it's quite reasonable. And then we estimated that a classroom is about 25 students. So a set of 25 kits for a classroom would cost $1,875, which is a fairly reasonable amount. And then we also estimated a yearly max production limit. So we assumed that 3 people working 2,000 hours a year, and each person could build a kit in 4 hours. And this would allow us to build 1,500 kits. And at this rate of profit, we would make $39,500 in 1 year of building kits. For our economic analysis, we also made a chart explaining what was shown in the previous slide. As you can see, the blue line represents units sold. The red line represents total revenue. The gray line represents total costs. And the yellow line represents total profits. And as you can see, our break-even point is right here at 304 kits, and our max production is at 1,500 kits. And the maximum profit, the gap between these two functions is $39,500.